This is a continuation of section 9.6. We're going to talk about solving right triangles. So what it means to solve a right triangle is to find all unknown side lengths and angle measures. So there are two scenarios that we can use to solve a right triangle. One is if we're given two of the side lengths and the right angle, and one is if we're given one side length and an acute angle and the right angle. We always have to know it's a right triangle to be able to do this. So if we're given two side lengths, we're actually going to use the Pythagorean theorem to find the missing side length. But we're not going to use that side to do anything else. We're going to put it off to the side as an answer, and we're going to leave it there. We're going to choose one of the acute angles. We don't know either one, so it doesn't matter which one we do. We'll circle it, and we'll label the two sides that were given to us as either O, A, or H, right, depending on what they are. We can then use inverse trig to find the measure of the acute angle. So that's going to be sine to the -1, cosine to the -1, or tangent to the -1. And then we can subtract that angle measure we just got from 90 to find the other acute angle. So let's look at our first example. We're given two sides here. We're given the 2 and the 3. So I'm going to fill in everything over here that I already know. So I already know that AC is 2, so AC is down here, that's 2. I know BC was 3, and I knew angle C was the 90-degree angle. So that's half of my problem done already. So now we need to find the other three things. We said we're going to use Pythagorean theorem to find the missing side. The missing side is our hypotenuse, so that's going to be AB squared equals, now the other two sides are 3 squared plus 2 squared. So AB squared will equal 9 plus 4, which is 13. Take the square root of both sides, and the square root of 13 is 3.6. So here for AB, we'll put 3.6. And then it's up to me which angle I want to find. So I'm going to find B. We knew the side opposite, we didn't know the hypotenuse, and we knew the adjacent. So using our information from solving for angles, we have O and A, which is tangent. So B will equal the inverse tangent of 2 over 3 because it's O over A. So doing that, we get that B is 33.7. So the measure angle B is 33.7 degrees. And our final step is we can do A is really 90 minus what we had for B. So 90 minus 33.7, and we get 56.3. So the measure of angle A is 56.3 degrees. Here's one for you to try. You can pause. The answer is posted on Google Classroom. Example 2 is another triangle where we're given two sides. So we're going to follow the same process. So let's fill in what we know. DE is 12. DF is 3 radical 7. And angle F is 90 degrees. We said we're going to do Pythagorean theorem to find the missing side, and the missing side is not the hypotenuse, right? 12 is the hypotenuse. So we're going to have 12 squared equals EF squared plus 3 radical 7 squared. If we type this in our calculator, we do have to be careful. I'll show us how we would put that in. We would start with parentheses, 3 square root 7. We would have to end our parentheses and then square that. We get 63. The alternative is 3 squared, which is 9, times the square root of 7 squared, and we get 63 that way, which is really 9 times a regular 7, because the square root of 7 squared is just 7. So my 12 squared is 144, so we can take 63 away from 144. So we have 81 equals EF squared. And when I take the square root of both sides, I get 9 is what is equal to EF. When I want to find one of these two angles, let's say I chose angle D. So we're going to have not the opposite. 12 is the hypotenuse. 3 radical 7 is the adjacent. So D will equal the inverse cosine of 3 radical 7 over 12. If you're not comfortable with the decimal, with the radical, you can turn it into the decimal first and round it. We're going to get a slightly off answer doing that. But if that's all we can do, that's fine. I would do inverse cosine, and I would try to use a fraction. And I already forget what my numbers were. We had 3 radical 7 and 12. So 3 square root 7 on the top and 12 on the bottom. Just so that I know I'm not messing up my radical with the division. So doing that, I get 48.6. So D is equal to 48.6. And we know we could use 90 minus that to find E. So if I took 48.6 away from 90, I get 41.4. So the measure of angle E is 41.4 degrees. Here's another check-in involving a 2 radical 7. We're going to pretend that's not there because I took it away. You can give this problem a try. Pause. Answers are posted on Google Classroom. All right, the other scenario was if we knew one side length and one of the acute angles. So the first thing we can do is subtract that angle from 90 to find the other acute angle. We're still not going to use that one. We're going to put it off to the side in our answers, and we're going to use what we have on the picture. We're going to circle our given acute angle, the one that we just subtracted from 90 originally. We're going to circle the given acute angle, and we're going to label the sides with O, A, and H. And then we're going to cover one of the missing sides and use just regular trigonometry to set up our equation and solve. So we're going to use the normal sine, cosine, and tangent, not the inverse. And then we'll repeat the above step to find the other missing side. We'll cover the other missing one to find that last side. So for example 3, let's fill in what we know. Angle H is 25 degrees. Angle J was our 90 degrees. And the length of HG or GH is 13. So to find the other angle, we could do 90 minus H, which is 25. So 90 minus 25 is 65 degrees. So G is equal to 65 degrees. We were given the 25 though. So that's the one I'm going to use to label H, O, and A. When I want to find the O side, we could pretend the H side is gone. So O and H, sorry, the A side, O and H is sine. So we can set up sine 25 equals O over H, which is JG over 13. The number's on the bottom, so this is going to be a multiplication problem. JG can equal 13 times the sine of 25. So we get 5.5 for JG. To solve for the A side, we could pretend the O side's not there. So now we have A and H, which is cosine. Cosine 25 equals A over H, so that's going to be HJ over 13. Again, the number's on the bottom, so we're going to use multiplication. 13 times the cosine of 25. And I got 11.8 for HJ. So there's one last one for you to try. You could either pause or end it now. The answer is posted on Google Classroom. But that is the end of section 9.6, solving right triangles.